Hello everybody. In this video we will be discussing the left and right hand limit. Alright, let's start by defining the left hand limit. First, this is how we write the left hand limit in mathematical notation. And we say the left hand limit of f of x as x approaches a equals L if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a and x less than a. Now you might be saying to yourself, hey, I still don't know what a left-handed limit is. Well, it's okay. We'll go over an example and that'll clear things up. Say we were given the following piecewise function. For values of x that are less than or equal to pi over 2, it's governed by the equation 2 over pi x plus 1. And for values of x that are greater than pi over 2, the graph is governed by sine of x. What if we were asked, what is the limit of f of x as x approaches pi over 2 from the left? Recall that the equation 2 over pi x plus 1 controls all the values that are less than pi over 2, less than x equals pi over 2. So if we trace the graph from the left all the way up until x equals pi over 2, we will see that the limit equals 2. So the limit of f of x as x approaches pi over 2 from the left is 2. You could also substitute pi over 2 directly into the equation that it's governed by. You get 2 over pi times pi over 2 plus 1, which equals 1 plus 1, which equals 2. Now what if this dot was open instead of closed? Recall from the definition, we aren't considering what the function evaluated at a is, in this case pi over 2. What we are considering is what the y values get closer and closer to as the x values get closer and closer to pi over 2. So it does not matter if the dot is open or closed, the limit is still the same. Now let's move on to the next definition, defining a right-hand limit. In mathematical notation, we write the right-handed limit of a function as such, and we say that the right-handed limit of f of x as x approaches a is equal to L if we can make the values of f of x arbitrarily close to L by taking x sufficiently close to a and x greater than a. Okay, now that we have the definition for the right-handed limit of a function, let's go over an example. Say we were given the following piecewise function. For values of x that are greater than 2, negative x plus 3 governs it. And for values of x that are less than or equal to 2, x squared governs it. What if we were asked to find the limit of the function as x approached 2 from the right? Well, if we trace the function towards 2 from the right, you can see that we get closer and closer to this value right here. What is that value? Well, it's governed by negative x plus 3, so if we substitute 2 in to the equation, we get 1. So the limit of f of x as x approaches 2 from the right is equal to 1. Now you might be wondering, does it matter if the dot is open or if it's closed? And again, just like before, it doesn't matter. And if you ever forget, just remember, the answer is whichever one you hit first when you're approaching from the direction of the limit. For instance, in this case, we're approaching from the right. We're approaching from the right. the first one I hit is this open dot right here. That's going to be my limit, 1. If I was approaching from the left, then my answer would be this value right here, 4. So that's an easy way to remember. Thank you for watching, and remember to like and subscribe if you like this video.